So our goal here is to use properties of chords in a circle. And we are going to identify first a major arc, minor arc, what a central angle is, and of course a semicircle. These we've all seen before, and we're going to be more specific about it now. So the first thing here, of course, this is my center right there. Center is often labeled with a C, but it actually never matters what you want to call it. By the way, the name of this circle now is Circle A. The name of the circle is now Circle A because the center has A, so that's how it's named. So, of course, we know that we have a central angle, like here. So what makes a central angle? It is an angle whose vertex is at the center. An angle whose vertex is at the center. Angle with vertex at center. And now, over here on the central angle, we have an intercepted arc. And this arc right here is called a minor arc. And what makes it a minor arc? Well, since the angle over here, and we'll be arbitrary about it, 42 degrees, whatever the central angle measures, that is the measure of the minor of the arc there. 42 degrees. So, to name an arc, we need some letters. So, let's put a B here and a C here. So the name of this minor arc is called arc BC. And we simply say arc BC. Technically, you could go the other way, arc CB. Notice I'm only using 2 letters because it's a minor arc. The way we write it as a number would be this. The measure of arc BC is 42. And it's not much different, you don't need to write this, it's not much different than the measure of angle ABC equals 42 degrees, or something like that. Actually, we can clean that up to say the measure of BAC. Notice that's my internal, or my central angle. Since the central angle here is 42 degrees, the minor arc is 42 degrees, so that corresponds to down here as well. So minor arc has to be between 0 and 180. Notice it cannot be either of them. Therefore, a major arc is going to be greater than 180, but less than 360. And over in my diagram, if I place another point out here and here. Now, if I'm talking about the arc that goes around this way, starting at B, but going through D, going through E, and ending at C, that is my major arc. And of course, there are an infinite number of them. And the way we need to label this one is we need 3 letters. Rather than saying from B to C, like we did here, we're saying from B, going through something else, ending at C. So the way we name that one would be something like this. B, D, C, arc. Arc BDC. And the way that we label it as a measure, same thing. The measure of arc BDC is going to equal what? Well, in this case, it's going to be the whole thing minus the 42, which will give me 318 degrees. Congruent arcs would be arcs in the same circle with congruent measure. And technically, it doesn't have to be simply the same circle. It could also be in congruent circles. But notice, for example, that if I had two different circles, this one here, and a clearly larger circle, and I was talking about this arc right here, and that arc measured 42, and this arc here also measured 42, clearly those cannot be congruent, because as we see here, just this distance here is clearly smaller than this distance here. So there's no way they can be congruent, because the two circles are not congruent. A semicircle has a measure of 180 degrees. So an example over here in my diagram, if I were to extend, notice that I need to have a diameter. Having a diameter now gives me a semicircle in actually two directions. And depending on how I name it, depends on the arc that I'm talking about. So if I look at the red one, that one has a name of arc BDE, starts at B, goes through D, and ends at E. Make sure I have my arc above. And if I were talking about measure, I would say the measure of arc BDE is equal to 180.